Why is predictive maintenance accurate for transit equipment failure prediction? Imagine catching a problem before it causes a breakdown. That's what predictive maintenance aims to do for transit equipment like buses and trains. It's like having a health monitor for vehicles. This approach is becoming a game changer in supply chain and transportation management. So, why does it work so well? It all comes down to the way it uses data and technology to see what's coming next. Predictive maintenance relies on sensors and Internet of Things devices installed on transit vehicles. These sensors track important things like temperature, pressure, vibration, and engine performance all the time. They gather a steady stream of information that shows how the equipment is doing. This data is stored and analyzed to find patterns that might signal trouble ahead. For example, if vibration levels increase slightly over time, it could mean a part is wearing out. These tiny changes are often invisible to the naked, but are picked up by sensors. Advanced analytics and machine learning models then process this data. They learn from past failures and operational conditions. For instance, they can recognize that a certain vibration pattern often leads to a brake failure after a specific number of miles. This means the system can forecast when a part might fail, sometimes days or weeks before it actually happens. Unlike traditional maintenance, which waits for something to break or follows a fixed schedule, predictive maintenance acts based on real equipment condition. This makes predictions more accurate and reliable. From a supply chain point of view, this accuracy offers many benefits. It reduces unplanned downtime because maintenance is scheduled before a breakdown occurs. That means fewer delays and better service for passengers. It also helps optimize maintenance schedules, so parts are replaced only when needed. This reduces unnecessary costs and extends the life of the equipment. When issues are caught early, small problems don't turn into big, expensive repairs. This saves money and preserves the value of transit assets. Predictive maintenance also improves inventory management. Knowing when parts will be needed helps plan spare parts stock and labor more efficiently. This makes the entire maintenance process smoother and faster. Plus, keeping vehicles in good shape boosts safety and reliability, which is always a top priority. Real-world examples show how effective this approach is. Some rail systems can predict up to 35% of signal failures a month in advance by analyzing failure history, weather, and location data. Buses that adopted predictive maintenance saw their breakdown rates drop by about 8% and maintenance costs cut by nearly 30%. These results come from the ability of data-driven models to continuously learn and improve their predictions. In short, the accuracy of predictive maintenance for transit equipment failure prediction comes from its foundation in real-time sensor data, smart analytics, and machine learning. It turns raw data into actionable insights, helping transportation systems run more smoothly, safely, and cost-effectively. This approach aligns perfectly with supply chain and logistics goals by making maintenance smarter, faster, and more precise.